packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today we have a guest, James Harr, who's going to be talking about his IPv6 pod project. And I guess the logical thing is let's talk about what that actually is. So James, welcome to the show. And what's the IPv6 pod project all about?
I'm going to rewind to a few years ago. Before that, I had been an IT practitioner that wasn't really interested in doing IPv6. To me, it was complicated. IPv4 was working fine for me and I knew it. But then I switched over to an organization that had IPv6 deployed in a dual stack environment and kind of renewed my interest in it. And I was like, okay, how does this work? Does it work? And as it turns out, it wasn't as scary as I made it out to be. And so the company that I work for right now is Internet2, and I work in the division that runs a national research and education backbone. And we kind of look like a large IXP for the research and education community. And so as I was sort of diving back into IPv6 and relearning a lot of the things that I kind of set aside and dismissed, I kind of wanted to see what usage was like. And so we had some NetFlow tools that I looked at to see where we were at. And I was a little disappointed to see that IPv6, not necessarily deployment, but usage specifically, wasn't as high as I expected, especially when you went and looked at like the Google IPv6 statistics that you see, where it trends upward very, very slowly. And we're getting close to that, 45 to 50% mark. But I was kind of curious as to why adoption wasn't that strong in the research and education community in the US. So I started asking around and digging into the NetFlow data a little bit more. And I found out that when you looked at specific organizations, if I knew that they were deploying IPv6 to the end clients, I would see, their usage go up to that 40 to 50% mark. But for a lot of the other organizations that exist within our network, when they don't deploy it to the end host, you don't see much usage. We'll see route advertisements for them. You'll see just a trickle of IPv6 traffic.
Yeah, because it's just the actual routers doing peering and that's it, right? And advertising.
Yeah, it's just sitting there saying, waiting to be used,
Right, yeah.
So a couple of organizations cited laziness, like we're lazy, we haven't done it. But I didn't really like that answer because laziness is usually a mask for something else. Within an organization, sometimes there's complexity, there's resistance to change, or there's some concern. So, I think at one point, someone brought up the idea that there's difficulty in running two networks in parallel. You're not just running a network, you're running an IPv4 network and an IPv6 network in parallel. So at that time, the transition mechanisms that I knew of to run IPv6 only were, DNS64 and NAT64, and those are what I knew about. So I went through the exercise of setting it up at home. And, after some testing, it's about what you'd expect. Depending on your operating system, it either just works or some applications have trouble. And, I was on a community call. We have an IPv6 working group, and someone told me about 464 XLAT. And, the first time I saw that, it was a bunch of letters and numbers. And I'm like, that's something an ISP uses. It's not something that I use. And they kind of described how it worked. And not only that, they told me that, hey, Android, Chrome OS, iOS, and Mac OS have this built in already. And you know what? You're using DNS64 and NAT64. So it's probably actually turning on. And I'm like thinking, what? It kind of blew my mind because when those devices were on that IPv6 only network with these transition mechanisms, things just tended to work. There were some things that didn't quite work, right? But they just worked. That's the thing that got me excited about looking at IPv6 only networks, or IPv6 mostly, is that this actually might turn into a deployment style or a deployment that you could actually run in a larger network with lots of clients, because that's where I came from. Was in my past, I worked at a campus network at a university. And so we had a lot of clients. And I think that's kind of where my mindset is, how can I deploy this to a large number of clients in a way that's not going to break things? So like I said, I got more interested in it. And then DHCP option 108 started to come around. And I think I actually heard about it on this show. And now you can start getting into a realm of where you can turn IPv4 off in networks without really breaking things that don't know how to exist in an IPv6 only world. So, you asked like, what's this IPv6 pod project about? So circling back around, it took me a while to set up these environments. There's a lot of knobs and a lot of settings on routers and a lot of, things that you need to do. So, in my mind, I'm running through the things to set up an IPv6 lab, and maybe I might forget something here, but if I do, let me know. But you need access to the IPv6 internet, somehow. You can get tunnels, you can get native, but you need access to it somehow. You need a router that supports IPv6. Today, that's pretty standard. Most routers, especially like home routers, will support IPv6, SLAAC, and RDNSS. That's pretty standard. What a lot will not support yet, or at least this is emerging, is Pref64, and that's the SLAAC option to say, hey, here's the prefix to configure your CLAT.
Right.
So after you have that, you need a NAT64 gateway. And what would be really convenient is if it were located in the router. And, oftentimes, when I've been looking at especially like prosumer type gear, it's not included. So, even if you're an IT enthusiast, I like to do this stuff at home, setting this up, that's another piece of gear that you'll need. You need a DNS server that can do DNS64.
Right.
And then a DHCP server with the option, with some configuration knob where you can turn on IPv6 mostly. And now you need to put all that together into a cohesive, setup. And not only that, you probably want to try out different scenarios. Like if you're serious about IPv6 only networks and you want to say like, how do I configure this right? You want to test software and operating systems in different environments to see how they'll behave. And so you're going to want more than one of those networks. You're going to want maybe a different SSID or a different VLAN for it.
Yeah, so you can just switch the client depending on what you want to test, right?
Exactly. And, I'm looking at that. I'm thinking I'm a fairly seasoned network engineer. I may have resisted IPv6 for a long time.
We'll forgive you.
Yeah, but it took me a while to set that up. And, I'm thinking about like, okay, it's not just network engineers that need to play with this. There's other people, there's IT practitioners, there's software developers that need to play with this. And they may not have the background to set these things up.
Or even to know all their options, right?
Yeah.
Yeah, so, you start giving them this acronym soup of things that they need to set up. And pretty soon they're like, you know what? I just am going to continue what I'm doing and hope that someone else will solve this.
Yeah, that sounds about right. It's not my problem.
Exactly. Yeah. But, that whole it's not my problem. Like, I hate that attitude, probably to a fault, because like I assume that everything's my problem. So I was excited about this, the prospect of being able to actually set up something to help people, get ready for that world. Either if it's getting over fear, if it's just I have some stuff to do, I need to test it, I just want to plug and go. I was kind of inspired by RIPE Atlas probes. Are you familiar with those?
Yeah, I think we talked about those in a previous show, but why don't we give folks an overview of what RIPE is doing with Atlas?
The probes, at least to my knowledge, they're these pre-configured devices the RIPE Atlas project sends out, and you plug them into your network, and it's a vantage point to provide testing points around the globe. So the thing that I really liked about that project is that these things just are pre-configured and work out of the box.
If I'm not mistaken, I think, Tom, they're Raspberry Pi based, right? In terms of just a small Raspberry Pi device.
That's possible. I think I ran it as a container when I was playing around with it. So yeah.
Yeah.
That's how I run it today, is in a container format. But yeah, they kind of had an initial round of, we're just sending these things out to people who are interested in providing a test point. And so when I was at a conference, I stopped by an Aaron booth and just, was making conversation and mentioned to someone there, hey, could we do something similar for this? And I think it was John Sweeting said that if you have an idea and you'd like to make it happen, Aaron actually has a community grant program. It's not a really complicated grant application process. Log in, submit your grant, and we'll see where it goes. The grant could pay for hardware, could pay for whatever was needed to get it started. So I ended up applying for that. I want to say back in 2023, Aaron graciously gave me some money to buy some initial hardware, and my work agreed to host a tunnel termination server, provide address space, and everything else. So what the grant was there for is to buy, more or less inexpensive commodity hardware, a little Wi-Fi router, install some software on it and pre-configure it and send it out to people. It doesn't assume that the person using it has access to IPv6. It will set up a tunnel to get, a /56 prefix. There's some default firewall rules on there, but it's really just there to say like, hey, here's a bunch of SSIDs you can connect to. And they're pre-configured to set up a few different environments, like one that's dual stack, just as sort of like a base, is my operating system going to puke when it sees IPv6? And
Yes, common starting point. Try and get both protocols running first.
Yeah. And, pretty much nothing does these days. You might be able to find some really old hardware or control systems that might, but for the most part, everything seems to be fine. There's another network that's IPv6 only, and it's the other extreme. It's, with no transition mechanisms. What happens if I only have IPv6 and there's no regular DNS, no CLAT configured? Will my application work? And then you get into sort of these transition mechanisms with NAT64, DNS64, 464XLAT, and DHCP option 108. And so there's different combinations of SSIDs that users of this could connect to, and they're just pre-set up. And so that's kind of what the project is. It's we bought a round of about 30 of these devices, sent them out to an initial group of participants, and that allowed them to test things. And so, who is this really for? And like I mentioned, it's not just for network engineers, but network engineers are a significant number of applicants because setting up these things takes time.
Yeah, and it takes a certain amount of experience and understanding in order to know how to build everything out that you require. It sort of reminds me a little bit, I don't know, and this is dating me now, but Tom, do you remember the California V6 Task Force and GoGo 6?
Mm-hmm.
They had the little CPE devices that they handed out that built automatic tunneling to hand out, basically to allow you to plug into a network and get you directly on the V6 internet by dual stacking that local network with a router advertisement and setting up the capability for it to tunnel once it got a V4 address on the device.
Yeah, that's right. I remember that.
That's really cool. I didn't know about that.
Yeah, it was an early project. Bruce Sinclair did this. It was actually a lot of fun. He ended out this. I still have the CPE device laying around here someplace.
You should plug it in and see if it still works.
No, it doesn't. I know that much because that tunnel endpoint termination isn't being maintained anymore. But it was a lot of fun to sort of see. He had distributed hundreds of those devices out there for folks to test out and use, just to promote getting folks to get some understanding about IPv6. So I'm really glad to see your project as sort of an incremental on top of what's going on there, because it is really difficult to go in and look, we're all probably a good portion of us have all set up Joule or set up something else of equivalent nature just to be able to get certain things up and operational for what you might want to test and play around with. But setting up DNS 6.4, if you're just doing raw and bind, is a lot harder than you think it looks when you're first initially reading the docs. So
it's funny because the software on it's based on OpenWRT. And as I was looking through the options and how to configure it, it was actually easier for me to set up two different pieces of software, a DNS server that's DNS 6.4 enabled, and then one that's not. Do a little bit of IP tables than it was to get one DNS server to do both.
Yeah, that sounds about right.
That sounds right. Yeah.
So I'm like, you got to set up views in bind, and like, no, I'm just going to install two and support forwarding to make it happen. So it's not the most proud setup I have, but it works, and it works pretty flawlessly. So
yeah, sometimes it's easier just to tell people to hop a single service than it is to try and tell them to debug what the heck is going on in the config.
Yeah, but the users of it don't need to really worry about it. It's just set up and it works. And if you connect to a network that's labeled with DNS 6.4, it just works. So not only network engineers for these things, but also like I'm thinking of IT support personnel, because at the university, we had an application support group that was responsible for making sure all these different applications work right, because they're the ones that get the calls when something doesn't work. And I'm thinking of, okay, they need to make sure they might be using the cloud email service for the organization, and they don't necessarily have control over the servers for that because it's software as a service, but they need to test to make sure that the email clients would work in an environment. So I'm thinking of like, if there's an IPv6 push within an organization, they need to test this stuff before they deploy those networks. And so I could see something like this being very valuable for them, where a network engineer could walk up, hand them this and say, hey, we're doing an IPv6 initiative to deploy IPv6 mostly networks. Can you make sure this software works when you connect it to this Wi-Fi router?
Right.
Similar with software developers. A lot of software developers, open source or internal, may not have an IPv6 network that they can hook up to right away. Their service may be available over IPv6, especially if it's hosted through a CDN, but they may not necessarily have a way to test it in those environments.
Right. Yeah, and I think the good point is that it's very easy to hand this device to someone and say, like, go home, plug this in, act like you're working remote, and tell us what your experience is in terms of connecting to the different networks to see how it performs. And then you can do obviously the same thing in the office itself. But sometimes having that initial, more sophisticated test at home person, it's a lot easier for them to just take their external connection, plug it in, and be off to the races and see if they can function or operate the way that they need to.
And actually, that's where a few of the applicants, that's what they did. They took it home first before they tried it out at the office, just because there are Wi-Fi SSIDs on it. They have a password on them, but they didn't want to get caught at work with that right away.
Yep.
There's a policy about that. So,
and that totally makes sense to me. I mean, that seems like a very pragmatic thing to do, is saying like, yeah, I don't want to blow up the office trying to get other folks involved. If I can test this myself from home, that it works and that I understand, which options work the best for us as an organization or work with the set of services that we have available to us or that we're using, that makes a lot of sense to me.
One thing that is worth mentioning is that it runs on WireGuard, because in the past I've set up IPsec tunnels and I hated every minute of it.
Yeah.
WireGuard just tended to work. So that was sort of the underlying technology. So it should traverse NAT without an issue as well. So it's designed to work. If you're behind NAT on IPv4 only, or at home, you should be able to plug this in and still use it.
Yeah. I guess the obvious thing is, since you've had a few folks that have actually deployed and used this thing now, what was their experience? What did they get out of it in terms of actually using it? And then I guess, was there anything that you did? Did you iterate on anything that you had deployed already?
I haven't iterated on it much more than fixing a couple of the typos in the configuration that we sent out with. There was a physical port that should have been connected to something, but it wasn't. And, there was a keep alive timer on the VPN tunnel, which is, that's all behind the scenes stuff that the user really doesn't care about. So the project right now, we've used up the funding from the grant. At some point, I'm going to seek to find more funding for it because I'd like to see this grow a little bit. But I need to collect the findings from the people in the project, send out a survey and gather it back. But informally, like the people that have OSs that with a CLAT, it just mostly works. Occasionally you'll find something that there's a hiccup where something doesn't quite function right. But for the most part, any OS with a CLAT just works. Windows will often have problems with DNS 6.4 and NAT 6.4, depending on the application. The oddest thing that I've found, in today's world, it makes more sense. There will be applications out there that will function just fine on IPv6 only networks, or, something with transition mechanisms, but certain parts of the application won't work, like sign in. But once you're signed in, there's an email service where once you were signed in, everything was fine. But to get through that sign-in process, you needed to have IPv4, because for the life of me, I don't actually know what was happening, but it was something that we discovered. And I want to say that there was a music app out there that was similar. Like once you're logged in, it's fine, but getting through the login process requires v4.
It's probably a outbound, like depending on the login service, like if you're using classic Windows, I mean, if the Kerberos authentication components aren't v6 published as a SRV record, then it's only going to work over v4. So it'll only do the lookup on the v4 side.
Yeah, exactly. And for example, a lot of logins for these larger tech companies are
third-party hosted.
Yeah, well, it uses OAuth or something where the authentication service isn't necessarily the same service that you're using to play music. And download the music and get your playlists. So the authentication service might not support it, but everything else does.
Yeah, or they didn't click the button on the CDN service to turn that on.
Exactly. So those are things that you don't discover until you use it for a long time, where you actually do have to log into the service again, or you might go to print something and find out that it doesn't work. So I think that's the thing that I think that a lot of people will find, is that certain applications may not work, but you might find things in the corners that don't work how you want, or may require a little bit of work to make them function.
James, I'm curious, did anyone run into any MTU issues?
Oh, yeah. I tried really hard. Like I looked around for a VPN that would function well, but would somehow do the fragmentation and reassembly, and everything squeezed through a WireGuard tunnel. So there's an MTU issue occasionally. A lot of services deal with it just fine. Occasionally we'll find websites that for whatever reason, the CDN, it expects a 1500 byte MTU. So it's not actually all that common, but when it does rear its head on the internet, it's very weird, because Happy Eyeballs doesn't necessarily fall back to IPv4 in that case, because it sees the connection established.
That's right. It's already done its job. It's like, MTU, not my problem.
The other really interesting thing that I've run into is, and this has been corrected, is that there was a service that was dual stack, but IPv6 was broken. And it was our own actually corporate SSO. And for the most part, no one had any idea that it was broken because, well, Happy Eyeballs took care of it.
Yeah.
One of our engineers actually ended up figuring out that when he was on a mobile provider, that mobile provider was doing a TCP proxy. When his phone would try to hit the SSO server, it'd go over IPv6, the TCP proxy would accept the connection, and then try and establish it back to the SSO server on his behalf, except that wasn't working. And so SSO on that particular mobile provider for our corporate SSO wouldn't work, which is another interesting find. And the thing is, I talk about these issues and they seem really scary, but for the most part, they're just kind of the corner cases and they're things that just need to be fixed.
Right.
And just like any other technology, as you start to deploy it, you're going to find problems, but that's going to happen anyway. In IPv6, you're going to find some problems when you deploy it. It's just, you got to identify them and fix them and know how to look at them is really what it boils down to.
I have to think that I don't have a clear picture of the folks that are using the pod and what their sort of background with IPv6 is, whether they've got a little bit of experience with it or they're veterans with it or they're completely, haven't used it at all.
I would say that probably about a quarter of them are fairly experienced at networking. There's probably another quarter of them that have not necessarily deployed IPv6, but are kind of curious. A quarter I got were software developers that, they did it for their job or they were open source developers. I ended up getting a few open source developers to apply for it. One of the tools that gets used in the Internet 2 community is HPN SSH, and it's an SSH client and server that's used to transfer data at higher speeds than the regular SSH client can, because, researchers pass around lots of data between HPC clusters, and SCP is still their tool of choice. So this piece of software is just a higher performance. It increases the windowing size and does a whole bunch of clever things to make it faster. And that developer is actually using that to implement happy eyeballs within the HPN SSH software.
Oh, very cool.
The thing that I hadn't done with this project that I thought would be kind of interesting is implementing networks with broken IPv6. It's not included, but, how does this application fail back? Does it? Eventually, I just kind of had to pick. There were only so many SSIDs that I could use up before it got a little ridiculous. So,
on the other hand, IPv6 never breaks. It always works. And IPv4 is usually the one that fails. So,
yeah. Oddly enough, a coworker was doing some performance testing on Kubernetes clusters, and he found out, and we still haven't figured out why, but he was doing some iPerf tests and he's like, why is IPv6 faster than IPv4? And I'm like, I have no idea, but it was 60 to 70% faster. And so I'm like, okay, that's a new one on me.
It could partially be routing performance over NAT performance, because every single one of the Kubernetes clusters that's on the v4 side is having to go through a translation state, probably all the way down to the port level, right? If you're doing that across multiple clusters, they're all having to translate, then you're going to get a degrading performance, versus if you just have a native address, no NAT translation, you just go straight through. At least fingers crossed, that's what you hope is going on.
It was actually interesting. We did it between the hosts too.
Oh, okay.
Like I said, I don't have an explanation for it. I'm just happy to see that that's the case.
We'll take the win.
Yeah, exactly.
That's right.
Maybe the next question that talks about it from a technical basis is, was there anything in terms of looking at how folks were using it for their environment? Was there any sort of reporting or information data gathering that you were doing off of this? Or was it just, subjective questions and answers with the given set of folks that you were working with? Or was there anything more formal that you did?
I need to send out a survey and collect the results from people since they've had some time to use it. It's going to be a lot of subjective, qualitative responses, not necessarily quantitative.
Sure.
What I would like to do in the long term, one of the things that I would like to see is reporting on, what software did you test and did it work or not? And privacy in this particular project was important. It's all voluntary reporting. What I'd like to do in the long term is actually see some of that stuff published and updated. When people find applications that don't work, can you share that with the community and share that with the developers so that they have a chance to fix it?
Well, what I would be really curious is if you can get the right folks to say, go ahead and bundle in what Atlas is doing with yours, and we get telemetry data if they click the button, and then they get the data gathering on their side automatically around what's going on. That would be pretty cool.
That would be really neat. Not sure how I would do that, but that's a really good idea.
Not that I'm trying to make you do more work, but I am.
Well, part of the deal was this was done in my free time. So
your copious amounts of free time, as it were.
Exactly. Yeah.
Your dog doesn't need you. So I don't know what you're talking about. He doesn't need that walk.
Yeah.
What did you find that was most interesting, at least for yourself experience wise, of sort of using your own project? Because I'm assuming you did. What did you find that was most interesting? And what do you think the audience would want to hear about?
Well, I think that when you turn on all the flags and you turn on DNS 64, NAT 64, Pref 64, and DHCP option 108, that you still offer, IPv4 for hosts that, can't do DHCP option 108, IPv6 mostly. For the most part, things just work. I was pleasantly surprised at how well that combination of technology, even if you take DNS 64 out of it and you just use 464 XLAT using Pref 64, and then you have DHCP option 108 with dual stack available, things just kind of work. It was pleasantly boring. If there's internal services that you use, you got to make sure that those are available, and you got to make sure that the firewalls are going to allow it through the NAT64 device, but it mostly worked. One thing I did find out was the project uses the well-known prefix for NAT64. I can't remember it off the top of my head.
64FF9B.
Yeah. And one thing I didn't realize is that there are some operating systems out there that will not use that if you're trying to connect to RFC 1918 space. So if you're trying to get to a private IPv4 address, it's going to not use that.
Yeah, that's actually an RFC standard. It's not supposed to.
Yeah, and I didn't realize that until I experienced it. So
yeah, that's how it's actually supposed to work. Yeah, interesting. I think it's funny that you mentioned, turn on all the options. The Christmas tree RA, we're going to have to come up with a new nomenclature for turning on all the translation services capabilities at the same time. So maybe this is colored lights and non-colored lights. Is this icicles? What is this?
Yeah.
For this option, because this is a whole brave new world we're wandering into here.
Turn that one over to the IPv6 marketing department.
Yeah.
But yeah, it's definitely interesting about what you could potentially do there. And I do think it's interesting about all the different options that are available, along with, and I don't know if this was something that you've considered too, around building in some NAT66, MPTV6 sort of option sets for folks to play with just as an optional basis. But, it gets into the whole, is this stateful, is this stateless, and how much fix up occurs for a given application or not, so that you can sort of get that flagged and be like, nope, that app requires state. We need a different transition mechanism for it. It would be nice if we could flag it and give it a different transition mechanism that's more stateful than the stateless stuff that we're utilizing. So that could be interesting in sort of pushing it through and saying like, oh, this needs an application proxy.
Yeah.
Some sort of reverse proxy to make this work versus maybe trying to push it through NAT64 and DNS64.
Or, just get the application hosted on V6 and
right. Yeah. So I think that would be pretty neat, but I imagine you'll get some of that out of your collection of findings, and hopefully folks will bring that up to you. But I would like to encourage everyone on the listening side, hey, you guys, you should hit up James and see if you can collaborate and help him out with this one and maybe have some fun.
Yeah. So if there's anybody out there that knows some other funding sources to pay for some of these, I would love to send out more free ones. I'm also want to work on a sort of bring your own hardware. The deployment of these things is more or less it's a Python script that generates a config file that I can blast onto these. And it's based on OpenWRT. There are a few operating systems. That's the one I landed on for better or worse reasons, because it's Linux. I can get Joule on there, install some software to make things work. But one of the things I'd like to do is sort of work more on the bring your own hardware, where if you can get OpenWRT loaded on a device, I can send you a config file. It's a little challenging with the wireless chipsets and picking the right interfaces, but I'm willing to work with people on that. I want to work on providing a VM image for people, where if they don't need a full-on router and they just want to load it into a virtual machine and they can do all the networking on the back end, that they could still use it.
So they could just plumb it into the virtual networks that they have operating.
Exactly. So, very similar to how Ripe Atlas has a container that you can launch.
Right.
You don't need to buy the hardware anymore. A lot of people have something where they can host a container. And a lot of people have something where they can host a VM.
Yeah, this would be pretty cool if you work with Ivan and build something with Container Labs. But
yeah, that's a good point. Yeah.
Yeah, that'd be very cool. Well, I guess the obvious is what's next around IPv6 for you. What do you see around the corner here that you are excited about or find super interesting?
Apart from what I've already mentioned, I am actually really excited to see the Windows CLAT come through whenever that happens. I know there was an announcement and it didn't make it into the Windows update of last year, but I am really excited to see what's going to happen when Microsoft includes that in the OS. And I haven't been able to test it. I don't know where you can get it.
It's not available yet. It's very, very limited, and anything that you do get is going to be time bombed. But Tommy Jensen's the one
I heard if you know the right person, you can get a demo image of it. But yeah, I'm excited to see that come to fruition because I think the 464 XLAT and the CLAT really solves a really large swath of problems with trying to move to IPv6 only.
I agree.
I don't know where in the Linux community, like I haven't really figured out and mapped in my head who's responsible for what parts of the Linux networking when it comes to like, I have a desktop OS, you have all these different pieces of software to manage the networking stack, not just the kernel, but the end user. But I'd like, if I had my way, I'd want to find those people and talk to them and convince them to include a CLAT in Linux distributions. Because I think that's another area where if you can get it in all the major OSs, it really paves the way to turning off IPv4. One of the other things I'm very interested in is, have you heard of a website called caniuse.com?
I have not.
This is used by web developers, and it's sort of a list of all the features of CSS and JavaScript and HTML and what browsers they work in and what versions of browsers they work in.
Ah.
The idea is, can I use this thing? And I'm not sure I'm going to have all the time in the world to develop something like this, but I'm putting my wish out there in the universe that if we had something like this for IPv6 features, I would love to see something like that.
Across site metrics of supported features on based off of platform type.
Yeah, like, can this particular email app, will it work on v6 only networks? Or with Windows 11, can I use a CLAT? Not today, but when we get a version of it, as long as you have whatever update of Windows 11, that includes that CLAT, now it will work and it will require configuration to work out of the box. I'd love to see something like that happen for IPv6.
Yeah, and all the caveats that go along with it. Like, hey, you can only use Windows CLAT or any CLAT on a Slack-based network if you're doing DHCPv6. All right. Well, how can folks follow you on the internet? How can folks reach out, get a hold of you?
So I'm on Blue Sky as James Harr. If you search for my name, Harr, you'll find me. And if you look, I'm on way too many Slack instances. So you can probably find me in the networking world somewhere in there. And whether it's, packet pushers, network to code, any number of different Slack instances, you have to DM me though, because I can't keep up with all of them. So
Fair enough. Fair enough. Well, I really appreciate you coming on and filling us in on the IPv6 pod project that you got going on. And hopefully, if folks want to get more information, we provided a show link for the project itself. And reach out to James. I'm sure he'd be happy to have more folks jump in, help out, and do some interesting things, especially around funding. So if you got some money.
Yep, it will go to good use. My time is free.
All right. Thanks so much. Take care. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long, and until next time, we'll see you on the IPv6 internet.